Hello students, hi everyone. Once again, welcome to my channel Competitive Maths by Balaji. We successfully completed second chapter, linear equation in one variable, and today we are going to look at new chapter, that is construction of quadrilaterals. Before constructing quadrilaterals, let us recall the basics of quadrilaterals, that is which we learned in class 6 and 7. Okay? Yes. Third chapter, construction of quadrilaterals, part 1. Quadrilateral. Let A, comma B, comma C and D be 4 points in a plane. Consider 4 points. Suppose point A, point B, point C, point D. These are 4 points. No 3 of them are collinear. Yes, what is collinear? If 3 or more points lie on the same line, then the points are called collinear points. Let us see the example here. Yes, suppose consider line L. It is line L. If point A, point B, point C, consider 3 points on the line. Yes, point A, point B, point C lie on the same line L. Therefore, these 3 points are called collinear points. First, suppose let us take this point as D. Now A, B, D are not collinear. Why? Because A and B lying on the same line, whereas D lies outside the line. So A, B, C are collinear points. A, B, D are not collinear points. Okay. Again, line segment. What is line segment? The line joining 2 points. Suppose it is point P, it is point Q. The line joining these 2 points P and Q is called a line segment. Here point P and point Q are said to be end points of line segment PQ. Yes. Now come to our definition. Yes. No 3 of them are collinear. See, A, B, C points are not collinear. A, B, C are not collinear. Why? Because they are not lying on the same line. Similarly, B, C, D are not collinear. C, D, A are not collinear. Similarly, the points D, A, B are not collinear. If you take any of 3, they are not collinear points. And the line segments AB join 2 points AB, we get line segment AB. Line segment AB, line segment BC, join point B and C. Yes, these 2 line segments intersect at their end point B. These 2 line segment AB, BC intersects at their end point B. Similarly, consider other line segment CD. Now, line segment CD and line segment BC intersect at their end points. Similarly, join DA. These 2 DC line segment and AD line segment intersects at end point D. Similarly, DA line segment, AB line segment intersect at their end point A. That is, the line segment AB, BC, CD and DA do not intersect except at their end points. Yes, except their end points. They do not intersect any other points. Okay. So, then the figure formed by these 4 line segments AB, BC, CD, DA is called a quadrilateral with vertices A, B, C, D. So, ABCD is a quadrilateral. ABCD is a quadrilateral. Yes, with 4 vertices A, B, C, D. Here, A, B, C, D. A, comma, B, comma, C, comma, D are called vertices. AB, BC, line segment AB, line segment BC, line segment CD and line segment DA. Line segment DA are called 4 sides of quadrilateral. Are called sides of quadrilateral. And angle Simply angle A or DAB. Angle DAB, angle ABC, angle ABC, angle BCD, angle BCD, angle CDA, angle CDA are four angles of quadrilateral or the angles of quadrilateral. Let us come to second example. PQRS is a quadrilateral. Why? Because see here 3 points P, Q, R. They are not collinear. Similarly, Q, R, S are not collinear. Similarly, R, S, P are not collinear. S, P, Q are not collinear. Yes, no 3 points are collinear. No 3 points are collinear, as well as line segment PQ, line segment QR intersect at their end point Q. Similarly, line segment QR, line segment RS intersect at their end points R. Similarly, line segment RS, line segment SP intersect at their end point S. Line segment SP, line segment PQ intersect their endpoints. Except their endpoints, they do not intersect anyway. Therefore, the figure formed by these four line segments PQ, QR, RS, SP is a quadrilateral. See, what about third example? Let's come to third example. No 3 points are not collinear here. A, B, C are not collinear. B, C, D are not collinear. C, D, A are not collinear. D, A, B are not collinear. Yes, first point holds good by the figure 3. Let us come to second point. Yes, line segment AB, line segment BC intersect at their end point B. It is okay. Now line segment BC, line segment CD intersect at their end point C. And line segment CD, line segment DA intersect at their end point D. But line segment BC and AD intersect the point other than their end points. So it is not a quadrilateral. Quadrilateral means the line segment must intersect at their end points only. Okay? Yes. So example 1 and 2 are the quadrilaterals, whereas third one is not a quadrilateral. Let us see the elements of quadrilateral or parts of the quadrilateral. Okay? Yes. Here A, B, C, D is a quadrilateral. Here quadrilateral, the name of the quadrilateral is ABCD quadrilateral. Okay? Yes. In which A, B, C, D are called vertices of the quadrilateral. Yes, a quadrilateral have four vertices, that is A, B, C and D. Now come to sides. What are the sides? Since the quadrilateral is formed by four line segments AB, BC, CD and DA. These four line segments are called sides of the quadrilateral. So AB is one side, BC is second side, CD is third side and DA is fourth side of the quadrilateral. Now come to adjacent sides. What are adjacent sides? Two sides of a quadrilateral which have a common vertex. Two sides of a quadrilateral which have a common vertex are called adjacent sides. Let us consider example. See, side AB and side BC having common vertex B. So side AB and BC are called adjacent sides. Yes, side AB is adjacent to side BC and B is their common vertex. B is their common vertex. Similarly, BC is adjacent to side CD. C is their common vertex. And we have remaining two pairs of adjacent sides and their common vertices. You have to write down that one. Okay? Yes. Next come to diagonals. What are the diagonals? See here, among the vertices, A and B are adjacent vertices. Similarly, A and D are adjacent vertices. What about A and C? They are opposite vertices to each other. A and C are opposite vertices. Similarly, B and D are opposite vertices. Yes, what is diagonal? The line segment joining opposite vertices of a quadrilateral are called the diagonals of the quadrilateral. Let us join, since vertex A is opposite to vertex C, join these two vertices opposite, we get AC is a diagonal. AC is one diagonal. Similarly, the opposite vertex to B is D. Similarly, opposite to vertex to B is D. Join these two opposite vertices of quadrilateral. Join these two opposite vertices of quadrilateral. We get another diagonal. So, here AC and BD are two diagonals of quadrilateral. AC and BD are two diagonals of quadrilateral ABCD. So in a quadrilateral we have two diagonals. Okay. Come to angles. What are the angles? Four angles, namely DAB, ABC, BCD, CDA. Here A comes middle. That means angle forms at vertex A, and this angle is known as angle DAB. Angle DAB. Similarly, second angle ABC. Middle is vertex B. So this angle forms at vertex B. This can be written as angle ABC. Next angle BCD. Vertex C is middle of the D and D. So angle forms at vertex C. This is angle BCD. Angle BCD. And next CDA. So at the middle we have vertex D. So CDA angle forms at vertex D. That is CDA. Angle CDA. These four angles also denoted by simply angle A, angle B, angle C, angle D. Angle DAB is simply denoted as angle A. Angle ABC simply denoted as angle B. Angle BCD simply denoted as angle C. Angle CDA simply denoted as angle D. Adjacent angles. The two angles of a quadrilateral having a common side are called a pair of adjacent angles. The two angles of a quadrilateral having a common side are called a pair of adjacent angles. Let us see. This is angle A. This is angle B. These two angles having AB as common side. These two angles having AB as common sides. So angle A and angle B are said to be adjacent angles. Yes, angle A comma angle B are a pair of adjacent angles and AB is their common side. Similarly, angle B, and angle C are called adjacent angles and BC is their common side. Angle B and angle C are called adjacent angles. BC is their common side. Similarly, we have to find remaining two pairs of adjacent angles and their common sides. Okay. Next, opposite angles of a quadrilateral. Let us see what are the opposite angles. The two angles of a quadrilateral which do not have common side. Two angles of a quadrilateral which do not have common side are known as opposites. See, angle A and angle C. Angle A and angle C are opposite angles, as the sides of angle A are AB and AD. Sides of angle C are BC and CD. There is no common side for angle A and angle C, Hence they are called opposite angles. And we have another pair of opposite angles, angle B, comma angle D is another pair of opposite angles. Next come to interior and exterior of a quadrilateral. For that, consider the figure. Okay. Yes. Here A, B, C, D is a quadrilateral. This quadrilateral A, B, C, D divide the board into three parts. Yes. Quadrilateral A, B, C, D is divided into three following parts. First part is interior of the quadrilateral. Yes. The shaded portion is denoted interior of the quadrilateral. And next, the quadrilateral ABCD itself, or it is known as boundary of the quadrilateral. That is A, B, C, D, A is the boundary of the quadrilateral. The line segment or the sides of the quadrilateral are known as boundary of the quadrilateral. Next, exterior of the quadrilateral. Outside of the quadrilateral is called exterior of the quadrilateral. All these things are exterior of the quadrilateral. Yes, let us try to recognize the points interior of the quadrilateral. Let us try to recall which points are lying inside the quadrilateral, which points are the boundary of the quadrilateral, and which points are exterior of the quadrilateral. Example, the points lying inside the quadrilateral, that is interior of quadrilateral, are P, Q, S. Yes. Point P, point Q, comma point S are interior points of quadrilateral ABCD. Now, the quadrilateral ABCD itself means it is also known as boundary of the quadrilateral. Boundary of the quadrilateral. Yes. Point A, point B, point C, point D, point Z are on the quadrilateral ABCD. Z are on the quadrilateral ABCD. Okay. Next, exterior, that is outside of the quadrilateral. Thus, the points X, point Y, point W. Yes, here point X, points Y, point W are on the exterior of the quadrilateral. Exterior of the quadrilateral ABCD. Okay. Now, next definition, that is quadrilateral region. That is quadrilateral region or area of quadrilateral. Quadrilateral region or area of quadrilateral. The interior of a quadrilateral ABCD together with quadrilateral ABCD itself is called quadrilateral region or area of quadrilateral. Yes, the shaded portion as well as boundary together forms quadrilateral region. That is area of the quadrilateral or quadrilateral region equal interior of the quadrilateral plus boundary of the quadrilateral. Okay, let us see about small concept, convex and concave quadrilaterals. Yes, convex quadrilateral. Quadrilateral ABCD is said to be convex quadrilateral if all line segments joining points in the interior of the quadrilateral also lie interior of the quadrilateral. Yes. For that, suppose consider ABCD is a quadrilateral and mark any 2 points in the interior of the quadrilateral. Suppose this is point L, this is point M. And join these 2 points, we get line segment. Yes, line segment LM lies in the interior of quadrilateral ABCD. So, such quadrilateral is known as convex quadrilateral. For suppose, take another 2 points X, Y. Take 2 points in the interior of the quadrilateral and join them. the line segment joining these 2 points, again xy also lying inside the quadrilateral, that is interior of the quadrilateral. So this quadrilateral is called convex quadrilateral. Yes, a quadrilateral ABCD is said to be convex quadrilateral if all line segment joining 2 points in the interior of the quadrilateral also lie in the interior of the quadrilateral. Okay, so ABCD is a convex quadrilateral. Next, concave quadrilateral. Quadrilateral PQRS is a quadrilateral is said to be concave quadrilateral if all line segment joining points in the interior of the quadrilateral do not necessarily lie in the interior of the quadrilateral. Yes, suppose consider 2 points X, Y. Join these 2 points, we get a line segment XY. Yes, XY lies, line segment XY lies in the interior of the quadrilateral. In the interior of the quadrilateral. Quadrilateral PQRS. Now consider another one. Let us suppose it is point U, which is interior of the quadrilateral PQRS, and this is point V, which is also interior of the quadrilateral PQRS. Now join these 2 points. See, the line segment UV falls outside the quadrilateral. That means the line segment UV does not belongs to interior of the quadrilateral. Yes, here line segment UV falls in the exterior of the quadrilateral PQRS. Means here the line segment XY lies interior of the quadrilateral, whereas line segment UV falls in the exterior of the quadrilateral. That means line segment not necessarily lie inside the quadrilateral. So this quadrilateral is known as concave quadrilateral. Okay students. Next, let us see types of quadrilateral or quadrilateral tree. Yes. First of all, consider this is a quadrilateral. Yes, we know that ABCD is a quadrilateral with no sides are parallel or equal. Yes, ABCD is a quadrilateral with no sides are parallel as well as equal. If in a quadrilateral a pair of adjacent sides are equal and opposite sides are not equal, then it is called a kite. So it is a kite. It has a pair of adjacent sides are equal. And opposite sides are unequal. So such quadrilateral is called kite. From the quadrilateral, if in a quadrilateral a pair of sides are parallel, if a pair of sides are parallel, then it is called trapezium. Yes, in a trapezium, GH and EF are parallel sides, whereas HE, GF are called non-parallel sides. Yes, in a quadrilateral, if one pair of opposite sides are parallel, then the quadrilateral is called trapezium. And here EF is parallel to HG, as well as HE side, GF side are called non-parallel sides. From this we get isosceles. Isosceles trapezium. Isosceles trapezium. In a trapezium, if non-parallel sides are equal, then the trapezium is called isosceles trapezium, in which here these opposite pairs of sides are parallel as well as non-parallel sides are equal. Non-parallel sides are equal. Then the trapezium is called isosceles trapezium. Next, from the trapezium, if non-parallel sides are parallel, then the trapezium is called parallelogram. The trapezium is called parallelogram. In a trapezium, if non-parallel sides are parallel, then it is called parallelogram. As well as opposite sides are equal. Then the trapezium is called parallelogram. From the parallelogram, if adjacent sides ij, il are adjacent side. If adjacent sides are equal, then it is called, rhombus. If in a parallelogram, at least one of the angle is 90. In a parallelogram, at least one of the angle is 90. Then it is called rectangle. Yes. Rectangle also holds good the properties of parallelogram. That is, opposite sides are parallel. As well as they are equal. If in a rhombus, four angles are right angle, then it is called square. If in a rhombus, four angles are 90 degrees, then it is a square. As well as in a rectangle, if adjacent sides are equal, then it is called square. Okay, this is called types of quadrilateral or quadrilateral tree. Okay, yes. From this we can say that square satisfies all the properties of quadrilaterals, all the properties of rhombus, as well as all the properties of rectangle, as well as all the properties of parallelogram, all the properties of trapezium, all the properties of quadrilateral. And the rectangle satisfies all the properties of parallelogram, all the properties of trapezium, and all the properties of quadrilateral. Similarly, rhombus also holds good the properties holds good by parallelogram, trapezium, and quadrilateral. Similarly, trapezium holds good the properties of quadrilateral. By this reason, we say that a square is a rectangle. A square is a rhombus also. Okay. Every rectangle is a parallelogram. Every rhombus is a parallelogram. Similarly, every parallelogram is a trapezium. Every parallelogram is a trapezium. Every trapezium is a quadrilateral. So that a square is a rhombus, a square is a rectangle, a square may be parallelogram, a square may be trapezium, a square is a quadrilateral. Okay, this is very important thing. This is very important concept. Okay, next we will see the think, discuss and write. Next and last question of this class, that is think, discuss and write. First question. Is every rectangle a parallelogram or is every parallelogram a rectangle? For that, consider a parallelogram and rectangle. Yes, in parallelogram we know that opposite sides are parallel. That is, AB is parallel to CD. Opposite sides are parallel. And BC is parallel to AD. Now also, opposite sides are equal. opposite sides are equal. That is AB equal to CD, comma BC equal to AD. And opposite angles are equal. These are properties of parallelogram. Opposite angles are equal. That is angle A equal to angle C, angle B equal to angle D. And consider the diagonals. Diagonals of parallelogram are not equal. That is AC is not equal to BD. But diagonals are intersect each other. For suppose let is point be E. Then we have AE equal to EC and DE equal to BE. That means diagonals of parallelogram are bisect each other. That means AE equal to what? EC and BE equal to ED. Yes. These are the properties holds good by parallelogram. Let us consider properties hold good by rectangle. Yes. Opposite sides are parallel. Opposite sides are parallel. That is PQ is parallel to SR as well as PS is parallel to QR. Also, opposite sides are equal. Opposite sides are equal. That is PQ equal to SR, comma PS equal to QR. Now, come at angle. Each vertex angle is 90 degree. Each vertex angle is 90 degree. Each vertex angle in a rectangle is 90 degree. So, each angle is equal. Angle P is equal to angle Q is equal to angle R equal to angle S. As well as opposite angles are also equal. That is angle P equal to angle R, comma angle Q equal to angle S. Next, diagonals are equal. Diagonals of rectangle are equal. That is PR is equal to SQ. Also, if diagonals bisect each other at T, then we have PT is equal to TR, comma QT is equal to TS. Yes, these are the properties holds good by rectangle. See, what are the common properties to parallelogram and rectangle? Yes, these two are common properties, as well as second also common property for both one, and these two are common properties for both parallelogram and rectangle, and these are not common property, and also these two are common properties. See, all the properties of parallelogram holds good by the rectangle. So that a rectangle is a parallelogram. Rectangle is a parallelogram. Also, see these two properties. The properties of rectangle are not holds good by the parallelogram. Therefore, a parallelogram cannot be a rectangle. Okay, this is about first question of thing discussion, right? Second question solution. Uma has made a sweet chicky. She wanted it to be rectangular. In how many different ways can she verify that it is rectangle? Yes, she wants to check whether sweet chicky is rectangle form or not. How many ways are there to check sweet chicky whether it is rectangle or not? Let us see. The following are some ways for Uma to check whether the seed check is in the form of rectangular or not. First one, she has to check all the angles is equal to 90 degree or not. If all angles of seed check is 90 degrees, then it is a rectangular form. And second condition, diagonals. If diagonals are equal, if the diagonals are equal, then sweet chicky is in the form of rectangular form. And third one, opposite sides are parallel as well as equal, and at least one of the vertex angle is equal to 90 degree. Then the seed check is in the form of rectangle. So Uma has 3 ways to check whether her seed check is in the form of rectangular or not. Okay students, this completes the part 1 of construction of quadrilaterals. This is very important class about basics of quadrilaterals. Okay, thank you. Have a nice day.